Gosh, I wish this was a little less gloomy. Okay, so sum of an infinite geometric series. Man, there's lag on that. Okay, so if there is a geometric series with its r value between -1 and 1, then the sum of the infinite geometric series exists and can be found using this equation given to you right here. All right. So it will specifically ask you to find an infinite geometric series. So looking at our first, and if it's not between -1 and 1, then we can't find the infinite sum. So let's go ahead and find the sum of this infinite geometric series right here. We need just two things instead. We only need a sub 1 and r because it's adding all the values up. We don't need an n value because it's adding infinitely many of them. So a sub 1 is going to be 20, and r is going to be our 18 divided by 20. I know it looks funny because it's not listed, but we're still just adding all those together. Let's refocus this. I'm wondering if it's like too bright in here. Oh, that kind of helped actually. Cover that up. Okay, that helped for like 2 seconds. All right, so we get 0.9 as our r value. So we'll plug that into our equation, those two values into our equation. So we get 20 divided by 1 minus 1.09, and this is our s value. So then s is equal to 200. Of course, you can plug that into a calculator if you want. Now, let's go ahead and find this infinite sum. So it doesn't say that, but find the infinite sum, or the sum of the infinite geometric series. So we're going to find this sum by using our equation. So we need a sub 1 and we need r. A sub 1 is equal to 3, it's that first value, and r is -2/5. We need to check and make sure that that's between, dang, that's glitchy, that is between -1 and 1. That's true, so we're good to go. All right, so we'll plug it into our equation. So we have s equals 3 divided by 1 minus -2/5. Plug that into our calculator. Come on. 3 divided by 1 minus -2/5. Maybe. All right, so what we end up with is 2.14 for that value. Dang, that's so glitchy. Such a bummer. Okay, so that next one there, you can see is just the equation for our finite geometric series. Just ignore that. We're going to go on to the next example. So we have -5/2 k minus 1. I hope you took that intermission to kind of try it on your own. If not, I'll keep going here. So we have a1 equals 1 because we have an invisible 1 out front. And we have that r is equal to -5/2. However, -5/2 is less than -1. So we can't have that. So we have that the infinite sum does not exist. Okay, so we're going to do a couple more examples. I would pause here, try these on your own, but we'll keep moving along here. So our equation is again written right there for us. So what we're going to have is our A1 value, and then our R value is whatever 15 divided by 5 is, or no, sorry, 5 divided by 15 is. So we get 1/3 is equal to R. Plugging in, we have 15 divided by 1 minus 1/3. 15 over 2/3. So we get 45 halves for that answer, which is 22.5, I think, right? Yes, 22.5 for that answer. Looking at our last one here, A1 is equal to -2, R is equal to 1/3. So we have that S is equal to -2 divided by 1 minus 1/3, or -2 is equal to, or -2 divided by 2/3, which is -3. I don't know why I put a 1 there. -3 for that answer. Okay, so that's it for that. Sorry about all the technical difficulties. Hopefully you're able to pause and see those videos. Have an awesome day.